Good morning. We're going to solve radical equations today, just a review from Algebra 2. The first thing you need to do is isolate the radical, so get it by itself. Raise both sides of the equation to the index power. Solve whatever's left, and then check for extraneous solutions. This just means substitute and see if it comes out true. So we'll show you how to do that. One thing to remember is that sometimes there will be a radical on both sides, and that's okay. You can't isolate it exactly that way. So we'll go through those steps. So first, you need to isolate this radical. So we want the square root of 8 plus 7 alone. So you're going to treat it as if it's a variable in any other equation and solve. So we have left the square root of 8 plus 7 equals 1. Now this is done with step 1. The radical is isolated, so we're going to raise both sides to the index power. Remember, if there's no power listed, that means it's the square root, so we're going to square both sides. That releases it from its little radical house on that side, and then you just solve this little resulting equation. So a equals -6. Now hopefully that's correct, so we're going to check to make sure by substituting it in. 10 plus the square root of -6 plus 7 is equal to 11. 10 plus the square root of 1 equals 11. 10 plus 1 equals 11. And so this is indeed the answer. That's really all there is to it. Of course, sometimes it will be written in rational exponent form, but hopefully you remember that that really means that this part is the cube root of 7p minus 1. We want to solve to get the cube root section alone, so we're going to treat it like a normal equation and move everything away from it. Since it is a cube root, we're going to cube both sides. Those are inverse operations. They undo each other, which means now we have 7p minus 1 on that side and -64 on the right. Add and solve. And divide. Okay, and before we circle that, we're going to check it by substituting back. I'm going to check it starting at this part, just because I like that better. So the cube root of -63 minus 1 plus 11 equals 7. The cube root of -64 is -4. And -4 plus 11 does equal 7. So the answer is truly p equals -9. All right, let's do a few more examples. This one is one of those where we already have the radicals. We can't put them together right now, and so we're going to solve from here. So we have a radical isolated, and we're going to do the inverse operation. So since we have a fourth root, we're going to put both sides to the fourth power. That again releases from the radicals, and we're left with a fairly simple equation to solve. All right, so after solving that, we get that d is 10, and we're going to substitute that in and make sure that's true. Since the fourth root of 7 does actually equal the fourth root of 7, that is the answer. Next one. So now we have variables on both sides. We have radical on one side. we're going to move everything that is not a radical over to the side together. So I'm going to move the 7a's over with the 8a. So 12 minus a is equal to a. We need to square both sides because this is a square root. And as soon as you kind of see that, you should be like, oh, I think I might be about to solve a quadratic equation. On this side, we're left with 12 minus a and a squared. Now, I know that in order to solve a quadratic equation, I need to move everything over and set it equal to 0. So I'm going to move the 12. I like my a squared to be positive, so that's why I moved it that way. And our a. So 0 equals a squared plus a minus 12. This is quadratic, so we need to factor. 0 equals. What are the factors of negative 12 that add up to positive 1? A plus 4, a minus 3. If you are having any trouble with that factoring part, please let me know and I'll help you. We're going to solve those mini equations by setting them equal to 0. So a is negative 4 and it's also 3. Now, maybe they're both answers or maybe we've got an extra solution there. So let's look at that. We're going to check them both. First, we're going to check negative 4. 12 minus negative 4, the square root, plus 7 times negative 4 should equal 8 times negative 4 if this is a solution. So the square root of 16 minus 28 should equal negative 32. The square root of 16 is 4, and negative 24 is not equal to negative 32, so negative 4 is not an answer. We'll check our other answer. 12 minus 3 plus 7 times 3 equals 8 times 3. The square root of 9 plus 21 should be 24. And it is. So the only valid answer is a equals 3. All right, hopefully you get the idea. Of course, you can try to solve this one on your own, but since I only put 5 examples, I put them very purposefully. So feel free to try to solve it on your own, or you can watch. Now, in this case, we do have 2 variable parts, and we're just going to keep it so one is alone. So this part here is going to be alone, and we're going to square both sides. Now be careful. Over here we have the x plus 9 because it just strips it from its little house. But this, the square root of negative 1, or so the square root of x minus 1 squared means the square root of x minus 1 times the square root of x minus 1. Don't forget. So you need to use the FOIL method to multiply that out. So the square root of x times the square root of x is x. The square root of x times negative 1 is negative 2 root x. And again, negative 1 root x. What am I doing? And then again for the middle. I got ahead of myself. Last, simplify. So x plus 9 equals x minus 2 root x plus 1. I see that right now I can cross off these x's. But if you're like, why did you do that? It's because really I could subtract an x from each side and they cancel out. So now we have 9 equals negative 2 root x plus 1. And we're going to go through the same process. We want to get this radical alone now so we can proceed. So we're going to subtract 1 from both sides. 8 equals negative root 2x and divide by negative 2 to get the radical alone. All right, at this point, your brain should be like sending out little warning symbols like, oh no, oh no, oh no, oh no, because the square root of a number is not going to be negative. So this has no solutions. All right. That is all there is to it. If you have any questions, well, actually, hold on. I think there should have been one more little step there. I'm going to square both sides here. So I have 16 equals x. I got a little ahead of myself there for a second. I was thinking of absolute value, so sorry, excuse that. It does have no solutions though, because when we substitute the 16 in, this is going to be the square root of 25 equals 4 minus 1. So 5 equals 3, and that's not true. So there is no solution. Sorry, I got a little carried away there, got all excited, and then felt like something must have been wrong. So that is how you do it. Have fun practicing. See you later.